Let's look at this diagram, Venn diagram problem. Slightly more involved than one we've done earlier. It says a group of 164 students was enrolled in at least one of three math classes, and we're going to call the classes A, B, and C for simplicity. Also, 98 were enrolled in Class A, 58 were enrolled in Class B, 78 were enrolled in Class C. We're just looking at the class roles of those various classes to come up with this information. We know that 21 students were enrolled in both Class A and Class C, 18 were enrolled in Class B and Class C, and 12 were enrolled in all three classes. And the question we're trying to answer here is how many students were enrolled in classes A and B together. First thing we want to do is begin our Venn diagram, drawing the universal set. And this time we've got three classes, A, B, and C, so we need three circles, one for each class. I'll let that be A, that be B, that be C. Again, the best way to start these Venn diagram problems generally is to start in the middle and work your way out. So I'd like to know what the number is in the overlap of all three circles. Those are the students that are enrolled in all three classes, and we know from what we've given that that is 12. There are 12 of those students. Looking back at the other information, we do also know that 18 were in B and C. Now the students enrolled in B and C were in this sort of football-shaped region here. And if there were 18 of them, and we've already accounted for 12, that must mean there were 6 more here. We know that 21 students were in A and C. A and C is this football-shaped region here. There were 21 of those. We've already accounted for 12, so that means 9 would be here. We know that 78 students were in C. And since we've already accounted for this many, that's 9 and 12 is 21, and 6 is 27. We've accounted for 27 of those 78. That means that 51 students will be here. Before I go any further, I might also comment that it says that these 164 students, each was enrolled in at least one of the three classes, so that means that there's a 0 out here. Didn't necessarily have to be true, but since they told us that at least one of the three class, each of the students was enrolled in at least one of the three, that means there's nobody among those 164 that aren't accounted for by at least one of these numbers. Now, I'm working my way up. I've used this piece of information, this one, and this one. I'm trying to use this piece of information which says that 58 were in B. That means 58 were inside this circle. But the problem is I don't know how many were here. As a matter of fact, if you look, that is exactly what they're asking us. How many students are enrolled in A and B? Now that's going to be this number plus this number. I don't know that though, so my first inclination, being a good algebra student, is to just put an X for that. I don't know that number. I can't say exactly. I also don't know this number, and I don't know this number, so again, I would probably be inclined to just create variables Y and Z and sort of represent the situation like that. I was able to get this 51 for C because I knew this piece, and this piece, but for A and B, I don't know this value I'm calling X. I do know something about the situation, though. What I do know is this. Since there were 98 students in A, and I've already accounted for 21 of those, I know that 98 minus 21, which is 77, represents everybody else in A. And everybody else in A is X plus Y. So I know that X plus Y has to be the rest of those 98 that are unaccounted for, which happens to be 77. I also know, doing a similar thing with B, that if there were 58 students in B, and I've already counted for 18 of those, then the remainder, which happens to be 40, would be everybody else in B, which is X plus Z. So I also know that. And really the last thing that I know is that if you add absolutely every number up, you're supposed to get 164. So I also know that if you just start adding everything up, Y plus X plus Z plus 9 plus 12 plus 6 plus 51, and if you want, plus 0, you're going to come up with 164. Now it's just a matter of arithmetic, because I know something from up here. I see this Y plus X, and I know that Y plus X, or X plus Y, if you want to say it that way, is 77. So really, I just need to add up 77 plus 9 plus 12 plus 6 plus 51. And if you add up all those numbers, the problem already looks simpler. I'll have Z plus, I'm just going to go ahead and do that over here. I'm going to take those numbers, 77 plus 9 plus 12 plus 6 plus 51, and add them. I get 16, 18, 24, 25, carry the 2, 9, 10, 155. So all those numbers, 77 plus all those, add up to 155. And that's got to be equal to 164. If you take 155 from both sides, you'll know what Z is. 164 minus 155 then is 11. Actually, that's not 11, that's 9. So Z would be 9. So now I know that there are 9 in here. I know that Z plus X is going to equal 40, and Z is 9, then X must be 31. I don't really have room to put that in there. And finally, if X is 31, then the question they ask, how many students are enrolled in A and B, which is this football-shaped region here, would be 31 plus 12, or 43 students enrolled in classes A, B, and C.